So BigQuery is for storing structured and semi-structured data. It is not for storing and processing unstructured data. That having been said, some people are playing with doing raster analyses inside of BigQuery, but at the moment, that's really not where we're optimized. I've seen examples of people rendering SAR data or processing SAR data inside of BigQuery. That's cool, but that's not where we're focused.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. Today on the show, I'm going to be talking with Chad Jennings, and he is the GIS lead at something called Google Cloud, and we're going to be talking about one of Google's products. It's a product called BigQuery, and yeah, I think you're going to find this really interesting, so stick around. Just before we get started today, I want to say that I was incredibly nervous at the start of this interview, so please forgive my somewhat clumsy introduction. Okay, let's go. Welcome to the podcast, Chad. Thank you for taking the time to do this with me. I realize you're a very, very busy person, and I'm so pleased that we could make this work. So you are the product manager for something called BigQuery. You're also the GIS lead at a little startup called Google. Yeah, and if I look at your LinkedIn work history, it's a little bit intimidating. Perhaps before we dive into the conversation about what you're doing now at GIS and Google and all these other things, perhaps you could just give us a brief overview of your work history.
Sure. And thanks very much for having me on. Let me also correct a couple, call it small but significant errors in your introduction. So I'm on the product management team for BigQuery. There's a whole bunch of us. It's a pretty sizable product. When I started at Google, I was the only product manager for BigQuery, and now the group is much larger. And I'm the GIS lead at Google Cloud. And so part of my work here is trying to figure out how to bring all of the innovation that we're bringing to cloud geospatial along with the GIS assets that Google proper has. So anyway, with that little correction, sure, I'll happily go through a bit of my history. So I presently work for Google Cloud, as we just went through. Prior to this, I came to Google from the startup world. And so I've done 4 startups. It's long enough ago that I've kind of lost count. A couple of them have gone fine. A couple of them are, smoldering craters in the ground elsewhere, but that's kind of the way startups happen. The one I did right before Google was really my entry into the combination of what we then called big data and geospatial analytics. And that really got my interest burning in this combination. So prior to that, I'd been a navigation engineer and aerospace engineer. My training is in aerospace. When I started really looking at the combination of geospatial analytics and cloud infrastructure, it got really clear to me really fast that there were pretty significant things holding people back, and you couldn't do an analysis with all the data that you had, so you had to shard the data, et cetera, et cetera. And so coming into Google and coming into this role was really exciting.
Okay, so what I'm trying to do there with the introduction, and let me first just say I apologize for those mistakes and thank you for clarifying that for me, is establish that you're an expert in your field. And I would just like to say to anyone who's still in doubt, please go along and check out Chad's LinkedIn profile. Like I said before, it's intimidating, and I think that you'll be impressed. So you said a few really interesting things there. We're talking about Google, and we're talking about something called BigQuery, and you talked a little bit about cloud infrastructure and geospatial functionality. Perhaps you could use that and sort of build on that and tell us a little bit more about BigQuery and how it relates to geospatial.
Sure. So BigQuery is Google Cloud's enterprise data warehouse. And so this is an immensely scalable data storage product and immensely quick data processing product. And a couple of years ago, we launched geospatial functions for it. So you interact with BigQuery with standard SQL verbs. In a lot of ways, it feels like a relational database, except you can have, relations and tables that are petabytes big. But to the user, you just type in SQL. And like I said, a couple of years ago, we launched a set of basically PostGIS lookalike functions. So the same syntax as PostGIS in BigQuery, so that we could do things like geospatial filtering, geospatial joins. And at the time, we were the first cloud data warehouse to have that kind of functionality.
So GIS, spatial data, it's everywhere. I mean, people often talk about this idea that 80% of all data has a spatial component, but let's just stay away from the 80% side and say lots of data has a spatial component. Why were people sort of slow, in inverted commas, to pick this up, to introduce GIS functionality to data warehousing?
The primary functions of a data warehouse are really like weblogs analysis, at least from the Google point of view. Weblogs analysis, transaction analysis, financial history analysis, things of that nature. BigQuery was invented to do weblog analysis because Google, being Google, has an awful lot of weblog data to crunch through. And so that's really where the use cases, the product leads, including myself back in the day, were focused on those sorts of use cases. And it was really with my coming into the company that I brought this geospatial background in and realized that there was a big gap here for the product because it wasn't serving GIS use cases at all. So that's why, it was me coming in and advocating for this, getting, engineering resources spun up and finding some engineering leads who were really excited about it. And that's how we grew the product. That started back in 2016, and then we launched it in 2018. And it's just been off to the races since then.
So I'd be really curious to know how we interact with this. So we talked about this SQL interface that we use to interact with data. How do I get to that? Is it built into, or are there integrations to sort of standard GIS products? Is it a web interface that I log on? Is that what's happening here?
Yeah, all of Google Cloud's products have either APIs or user interfaces or UIs, or generally speaking, the UI is backed by the API. And BigQuery is no different. So if you search for BigQuery and you go to the console, you can sign up for this thing called BigQuery Sandbox, where you don't even have to enter a credit card or any billing information, and you can kick around the product in our free tiers, which are actually pretty significant. Just in the free tier, you have a terabyte of processing free per month, and you can load up to 10 gigs of storage. And so you can try it out that way. But the user interface, there's a SQL composition window where you would type in SQL commands or copy and paste them from examples that you find on the web. And then you press run query, and the engine then processes your commands and returns your result. And then you can look at that result in a variety of different tools. As you were talking about, standard geospatial tools, there's a connector for QGIS. Then there are business analytics tools like Looker and Data Studio. Data Studio, by the way, just launched support for Google Maps base maps. So that's a pretty fun thing to try out. And we have a tool called BigQuery GeoViz, which is a facility where you can just render the results of that query directly on a map with no transforming of data, no transferring of data. It's really slick.
It sounds really amazing, and I love the fact that there's lots of different ways of getting at this. So I think a lot of people listening to the podcast will be comfortable with the idea of using SQL to process data, to write functions and execute statements, and will understand the power of that. Could you give us an idea of what it takes to get data into your database, into your system? And of course, I'd really like to have an understanding of how big this thing is. I mean, it's in the name, it's BigQuery, but how big is BigQuery?
Let me take those questions in turn. Obviously, a data warehouse or any data processing engine is really useless if you can't get data into it. BigQuery has a number of different ways to do it. You can do batch loads of data. There's a command called BigQuery BQ load, and that's, there's no charge for loading data. And we have customers that can load, using best practices, which you can find on the web, they're loading upwards of a petabyte per day, which kind of hints at your second question. We also have a streaming API, which interestingly, a lot of our GIS customers are using for things that look like industrial Internet of Things type applications, like telematics data, vehicle data. They'll stream that into BigQuery, and we have customers that are doing up to 10 gigabytes per second per table. So that's a very, very, very fat pipe coming into the product. But those are for, call it, data that you're generating in real time. If your use case is more like you've got a bunch of geospatial files, like whether they're shape files or something like that, or geotiffs, or it's not geotiffs, like geojsons. BigQuery doesn't do imagery. We should talk about that later. But if you've got files that you want to ingest, we've partnered with Safe Software, and their tool is called FME, and they can transform something like 400 or 500 different geospatial data types and materialize them as BigQuery tables. So that is a very powerful tool. It's available in the Google Cloud Marketplace, and they've got a pretty generous free tier as well. So, if you've got 1,000 shape files that you want to load into BigQuery as a table, you can use that product. Oh, and you'd asked also about how big is big. So providing a little bit of color there. Yeah, Google doesn't name products. We go for descriptive names. So BigQuery is the big query engine. Google Cloud Storage is Google's cloud storage facility. We try not to be particularly creative with names. We want to make them descriptive. And so BigQuery really does live up to its moniker. The way I like to explain it is this. Our largest customers have in excess of 250 petabytes in storage with us. The largest single queries will routinely span several petabytes in a single query, and those queries can finish in as little as a couple minutes. Actually, using things like partitioning and clustering, you can get queries over petabyte tables to run in just a few seconds, which is pretty impressive.
Yeah, absolutely. But I think also when it comes to Google, our expectations are really, really high. So it is very impressive. But also, I mean, you're the biggest kid on the block, if I can say it like that. So one of the things that really struck me in one of our earlier conversations was that even though you have this massive data processing engine and this huge amount of capacity, you never, ever once talked about big data. Is there a reason for that? At Google, do you think about data as being big, or because you have so much capacity, is it just data?
The short answer is we just call it data because, it's all big and it's getting bigger. So, even customers that are processing, smaller numbers of terabytes or gigabytes or whatnot, their data needs are growing every month and every year. And so this issue of scaling to big data, we've given up on the big data term. We just call it data. As an example, there's a funny story that also hints to our scale. One of our product managers was giving a talk to one of our larger customers. And in the talk, it was a roadmap talk. And so there was some, establishing facts. And there was one like, big facts for BigQuery. Largest customers, 250 petabytes. Largest single query. At that time, it was 5.2 petabytes, where the query engine scanned 5.2 petabytes in one query. And there was, he was giving this talk to about, 30 people, like 7 or 8 rows of desks. And one fellow in, the last row was thinking to himself when we went through that slide and said, I can do better than that. I'm a customer of this and I can actually, I've got a table that's about 5 petabytes. And so while this talk progressed, he concatenated, but he copied that table 3 times and appended it to itself. And so he created this monster, 17 petabyte table, and then he ran a simple query on it. And so before the presenter had finished the talk, this fellow raised his hand and said, "Hey, can we go back 3 or 4 slides?" Yeah. No. The one with the 5 petabyte. I just broke your record. See? And he got up and he, brought his laptop up and, he'd just run a 17 petabyte query. So it's that kind of scale that this product unlocks for folks.
Like, obviously that's amazing, but what makes it more amazing for me is the idea that this isn't happening, that it's not just one query at a time that's running on this compute engine that you have. I'm assuming you have lots of different customers that are all simultaneously running queries all the time.
Yeah, BigQuery is a multi-tenant system, which means, Google has, these vast data centers with, millions of computers in them. And, BigQuery as a product, we buy capacity from Google and we reserve that. And then when customers come in, we'll give them, access to the capacity that they've purchased. And so your query may run on a machine. And then when your query is done, that machine clears its cache. And then my query might run on that machine. And so it's really important to note, though, that in a multi-tenant system, And this is, by the way, how like many of Google's services, like the ones that you've probably heard of, like Gmail, search, YouTube, right? The compute that serves these things is ephemeral in these machines. And so Google has these job allocation servers where you can, put a job on a machine, and then it goes, and then when it's done, that machine is available for somebody, maybe even from a different part of the company. But what's really important to stress here is that when customers come to us, when enterprise customers come to us and say, look, this is my data, right? Absolutely. Like when you pay as somebody coming to BigQuery, when you pay BigQuery or use the free tiers, it's your data. Google isn't sharing it. We're very, very good at managing putting your data into a computer to run a process and then flushing it out so that somebody else can use that, because that's how we work many of our products. And so that privacy aspect of being in a scalable multi-tenant system is really important for folks to take away.
I really appreciate you taking the time to clarify that, because privacy, of course, is a big deal, and especially when we're talking about data, and dare I say it, especially when we're talking about location data, because that is intrinsically private. I'd like to sort of move off a little bit now and talk about another aspect of this, which I think is really important. So we're talking about cloud GIS here, and I think part of the magic of BigQuery, at least the way I understand it, is that you're completely hiding away all the complexity of running geospatial functions on a massively parallel system. What does this mean for cloud GIS going forward?
For the user, what it means is you load your data and you write your query, and your data could be gigabytes, it could be terabytes, it could be petabytes, and you don't have to worry about scaling the resources behind it. You just write your query and press run query, and then you get your results. So that's really like the fundamental value proposition to the user experience that BigQuery offers. When you talk about cloud GIS or doing GIS in the cloud, that's really, I guess, no pun intended, but it's a really multidimensional question. And that is, you've got tabular analytics. The GIS folks would call that more vector, right? Database folks come to this conversation and want to talk about tables. So there's tabular analytics, and then there's imagery analytics, and then there are data assets, and then there are compute assets that you can bring to those different dimensions. And so when you start unlocking the capacity for, say, tabular analytics, you start enabling folks to do stuff that they just couldn't do before. Here's a for example. I spoke about this customer's use case at a conference a few months ago, and they are using imagery analytics in conjunction with tabular analytics to do worldwide food production analysis. So they use a product called Google Earth Engine. Within Google Earth Engine, you can do image recognition, or you can process Landsat imagery, and you can identify from the spectral signature in the image whether a particular parcel of land is growing corn or soybeans or whatnot. And so they're pulling out what crop and how many hectares of what crop are being grown for areas, say, like all of Argentina, all of South America, all of Europe, Ukraine. I mean, like, they're really doing this analysis on this huge scale. And then they get a table of this polygon with these coordinates is producing, this crop, and this one is producing this other crop. And then they can combine that with weather data that we have for people to use inside of BigQuery, and combine that in a machine learning model all inside of BigQuery to make predictions about how much soybeans the Ukraine is going to be able to produce in 2021, given 2020's production environment. I'll just wrap that up and say, you asked about what cloud GIS is, and I imagine cloud GIS is this multi-dimensional geoanalysis capability that is unfettered from traditional scale blockers, so that folks like this company can do analyses that are really global in scale, whereas before they would just have to do it for a neighborhood at a time.
I think that's a really good way of putting it. And to be honest, that's exactly what I was thinking. I couldn't help but draw a parallel between some of Google's other products, for example. So I'm sitting looking at a Google Doc at the moment. So this is something, obviously, a cloud-based product, and I use Google Drive and I use Google Sheets, and they just work together. Like, I don't need to know any specific skills to use Google Docs or Google Sheets. My skills with Excel, for example, they're transferable for the most part. And this is kind of what I'm getting out of what you're talking about here when you speak about cloud GIS. It doesn't feel like, for a user anyway, or for a geospatial practitioner, that there's a huge leap here. It feels like I could take my skills that I have today and just move them over into this kind of environment. Now, granted, not all of us are going to be working with data at this scale, but it feels like, okay, well, if I know SQL, I could use this. If I'm into remote sensing and image segmentation, then I could use Google Earth Engine, for example, and I could use those two products together. Am I on the right track here, or am I completely wrong?
No, that's definitely the right track. And part of my job at Google is to make that, when you say use those products together, there's a lot of devil in the details there. And part of my job is to make those products work as well together as we possibly can. You've mentioned some of those other products that Google has, like Sheets and Drive and Docs and whatnot. One of the reasons they're successful is that they don't ask people to learn new skills to use them. So the better things work together without folks even noticing that they're using multiple products, like, the better it is for them. So we're earlier in that journey than, say, Sheets and Docs on the GIS side, but that's definitely where we want to be going.
I think this is really exciting, because this is one of the few times where I've heard about somebody doing something, or a company, I should say, doing something really sort of amazing in this space, where it doesn't feel like I've got this sort of huge learning curve in front of me if I want to get involved. Like, I'm like you said before, the devil is in the details, and I'm sure I'm sort of glossing over things a little bit here, but I hope that the listeners understand what I'm talking about. I would kind of like to move off now and talk about some of the use cases, because I think you've done an amazing job of describing what BigQuery is, what it does, and the scale of this thing, and what we might need to do to sort of get involved, how it works, that kind of thing. But it would be really interesting to hear some use cases. Like, what does this look like in the wild? Who is using it, and what are they using it for?
Let me give you a use case I'll start with a specialized one, and then we'll move to a couple more generic ones. So I described a use case before where a company was using Earth Engine to do analysis on images, export that analysis to BigQuery as tabular data, and then do machine learning on that tabular data. I have another one like that I really like to describe. This one's from a group called the Global Fishing Watch, and their mission is to help countries identify, bad behavior at sea. And they do the following. So they can look at, I think it's the Sentinel radar imagery that's inside of Google Earth Engine, and they can find the radar returns for every ship on the ocean. You can't hide your ship. If you're a bad guy, you can't hide your ship from, a satellite radar. Now, the good guys out on the water are all broadcasting something called AIS. And that basically is a satellite service, where ships broadcast their latitude, longitude, their identifier, their heading, velocity. You get the point, right? It's telematics. And then Global Fishing Watch does this massive diff operation between the radar imagery and the AIS imagery to find the dark fleet, to find the fleet of people that are present in the radar, but not present in the AIS data. And those are folks that are potentially up to no good, because they should be broadcasting and they're not. And they've actually had some fantastic success in bringing some nefarious actors on the sea to justice. There was an article in the Associated Press, I think it actually won a Pulitzer Prize, where there were reports of human trafficking and basically kidnapping and piracy out in Indonesia. And some of this analysis was available to help identify and locate some of these ships. So, as a humanitarian use case, Global Fishing Watch has been able to use this radar imagery analysis in Google Earth Engine, export that to BigQuery, and then do that diff operation with the AIS data that they have in BigQuery, to produce a list of people to go check in on.
Nice to hear like your power's being used for good, if you understand what I mean. It's always nice to have an example where people can relate to and like, yes, geospatial is doing some good in the world. I have to admit though, when you first started talking about the Dark Fleet, part of my mind immediately assumed that this was some kind of Star Wars reference.
No, nothing. Well, it's certainly that dramatic, but nothing that cinematic.
So we've come a long way in the conversation. We started off, briefly talking about your history, where you've come from. We talked a little bit about, BigQuery, what it is, what it can do, and now you've given us a few really interesting use cases. I wonder if you could talk about what it isn't, or a use case that this is not suited for. Give us an idea of when we should avoid using something like BigQuery.
I'm happy to talk about that, but there were two other use cases that I wanted to describe really quickly to help give people a more traditional understanding of what this is used for, and then one that's like straight, like ready for a cocktail party conversation. So if I may.
Perfect. Let's dive in.
Okay. The primary use case for BigQuery GIS is essentially filtering and doing geospatial joins on polygons and points that are stored in BigQuery. And so we have a number of customers that are doing things like, actually, this is kind of another data for good one, but they're doing traffic analysis. They record position, speed, and acceleration. And so they can identify hazardous driving behavior. Their fleet of sensors are actually commercial vehicles. Folks like Federal Express and UPS all hire telematics companies to collect data on their delivery vehicles and then report them back to the company. And so you can infer what global traffic is like from this sample because there are just that many delivery vehicles out there. Developing those kinds of insights like, I see a lot of heavy braking here in these weather conditions. That means the corner of 5th and Elm is probably a problem. City planner, let's go put a stop sign out there. Things like that certainly constitute more traditional use cases for this. But the one I wanted to describe that's ready for a cocktail party conversation, I am always trying to find use cases that are both interesting and educational. And so, Daniel, let me ask you this question. What kind of astronomy background do you have?
I like to look at the stars. That's it. Excellent.
We all do. Perfect. But did you know that the coordinates that astronomers use to map the stars are essentially the same as the coordinates that we as navigation engineers or geospatial analysts use to map points on the Earth?
No, I wasn't aware of that. And immediately I'm thinking that sounds like a challenge in an expanding universe.
True. We're going to keep this to doing math on the inside of a sphere as opposed to letting our minds expand with the expanding universe. But latitude and longitude are exactly analysis to right ascension and declination, which are the angular measures that astronomers use to map out where the various stars are. And so one of our Google solution architects actually mapped a whole, and by a whole bunch, I mean terabytes worth of radio astronomy data into Google GIS, into BigQuery GIS, and just everywhere it was supposed to be right ascension, he said, I'm just going to pretend that's latitude, and everywhere is declination, right ascension is longitude, latitude is declination. He just made those variable swaps, and all of the post-GIS syntax verbs just plain worked. And so he was able to do clustering, and he was able to map new radio phenomena doing that. And so I just thought it was awesome that, using terrestrial coordinates, that were really developed in the 16 and 1700s, you can actually now do astrophysics.
It is mind-blowing, and I'm really pleased that we stopped the conversation there and assumed we were thinking about us being inside a sphere and doing maths in there as opposed to expanding the sphere over time. I think that would have been too much for me.
Yeah. I'm sure. Maybe somebody listening will that math will grok in their brain, and they'll be like, "Oh no, I totally know how to do that." But if your readers are curious, they can search for, or if your listeners are curious, I should say, they can search for "Querying the Stars" and BigQuery, and they should find the article. It's a great read.
I think I'll do that for them, and I'll put a link to that in the show notes. But, Chad, you're not getting off the hook. My earlier question was, so when is this not the right answer? I think you've given us some great examples of all the amazing things it can do, but when should we not be using a tool like BigQuery?
Okay, great. Thanks for bringing that back up. So BigQuery is for storing structured and semi-structured data. It is not for storing and processing unstructured data. That having been said, some people are playing with doing raster analyses inside of BigQuery, but at the moment, that's really not where we're optimized. I've seen examples of people rendering SAR data or processing SAR data inside of BigQuery. That's cool, but that's not where we're focused. The places where BigQuery really shines, when you've got like latitudes, longitudes, line strings, polygons, like that's what our geospatial data type is really focused on. So if you've got imagery analysis or a lot of unstructured data, or if you've got a bunch of unstructured data, you can have a look, but BigQuery might not be the best one there. As I said, some people have found utility there, but that's not where our sweet spot is. And if you've got imagery to process, then you're going to have to use one of our sister tools like Earth Engine, Descartes Labs. Those are the two big ones if you're going to do imagery analysis in conjunction with BigQuery.
Thank you for that. I think that's always really interesting to get the other side of the picture when we talk about tools and technologies like this. I would kind of like to move off now and talk a little bit about the future. And so I think we've brushed on this a little bit, but what do you think the impact of this is going to be? Like this kind of infrastructure, this kind of access to compute in terms of geospatial cloud analytics?
That's an interesting question. Generally speaking, if folks ask you to make a future-looking prediction, you should calculate your expected lifetime and then make a prediction for some number of years beyond that. I'm not going to be quite that bold, but I will say this. Geospatial analysis has been hindered by just lack of ability to scale for a lot of years. That applies to like data analysis in general. And what that has led to is 10 years ago, people were creating data lakes and they knew that their data was valuable. So they were pouring their data into data lakes and they really didn't know what they were going to do with it, but it was too valuable to throw away and storage got really cheap. So we're going to hold on to it. So now those data lakes have like nobody's been swimming in them. Nobody like they're still just there. Like it's 10 years and terabytes or petabytes of data that nobody's waded through. So now they're kind of like data swamps. With the tools that we have now, you can start hunting around in this legacy data pretty efficiently and find out if there are gems there or if you can just get rid of it. So people will start going back into the data that they've collected for the last N years and be able to make use of it. So that's the looking back. In the looking forward, folks will be able to, if there's much less cost to collecting, streaming, storing, and processing data, folks can make applications and analyses that leverage data much more efficiently. The examples that I gave, mapping of food production and combining it with weather data to predict next year's food production. That service happens on a global scale because the data provider, Earth Engine, and the infrastructure, Earth Engine and BigQuery, can operate at that scale. So I think it's really going to take the brakes off a lot of folks.
Almost an overwhelming future when I start to think about the possibilities. I want to stay with the idea of GIS in the cloud just for a second here, because I think a lot of people listening to the podcast will have experienced the synergy, I guess, that starts to happen when you have a centralized database somewhere. Could you imagine like more and more of these databases in organizations moving from being local in the organization to being on the cloud, for example? I realize a lot of people are doing this, a lot of organizations are doing this already, but I'm sort of envisioning a world where instead of sending data to someone, I send them a link. Here's the data here. It's on BigQuery. It's on this other product. It's somewhere else. But that sort of interchangeability of links as opposed to moving data around, having it centralized in one place.
Yeah, this is, by the way, is the trend of our technical lifetime, whether you're involved in geospatial data or not, like the movement of data from the cloud and the other trend of moving compute to where your data is instead of pushing your data around is absolutely the way things are going right now. I mean, you can look at any Gartner or Forrester report and see that, zettabytes are going to be queried by some date in the future. I barely even know what a zettabyte is, but like these statements of how large data is getting, they're almost comical until you're suffering from the fact that your data is too big for your infrastructure. I definitely think that we will get to the point, like in the same way that folks that are using online documents are sharing links to the documents instead of sharing the actual document, folks will share links or access to a data set rather than trying to fit that data set onto a USB stick. If you really want to get future looking here, the other trend that's really exciting is that companies like Google, so Google is definitely doing this, other companies are doing this as well, so I want to hand out props where they go, but they're working hard to make the technical level necessary to interact with these tools lower and lower and lower and lower. So a lot more drag and drop, like that ingest tool that I talked about before, FME, that's a drag and drop tool. Like you create data pipelines by dragging boxes and clicking on parameters and then pressing go. BigQuery, you don't have to specify what the servers look like. And so more and more of these tools are approaching no code or low code, which means that now it's not just GIS practitioners' creativity that gets brought to bear on these data, which by the way is now easier to share, but it's John Doe or Jane Doe or whomever. And so when you start putting tools and data in the hands of millions of humans, you unlock a lot of creativity. And it's what the most fun part of my job, honestly, is what people do with the tools that I make. Like that's absolutely it. So the more people we get those tools to, the more fun it becomes.
I really agree with a lot of what you said there, this low code, no code future. I mean, we can see it happening constantly. People are talking about lowering the barriers to entry, so making this more available to people. And that's kind of what I see in your product, BigQuery here. So we talked a little bit about this during the conversation, that it didn't feel like we needed a ton of new skills to sort of really get involved with this. Another thing that stuck out for me in the last piece of the conversation was the network effect. So if the internet has taught me anything, it's that the network effect is the killer app. If something's going to succeed, it's going to be because it gets better the more people that use it. This is, we're all focused on this. And when I think about centralizing data in things like BigQuery, Cloud GIS, this is what immediately springs to mind. This is the network effect just with data.
Yeah. And, let's spend another moment in that utopia where like everybody can have access to all the data and, everybody has the necessary skills and, maybe the skills, are lower than they are today. And that's great. And, in that you unlock the full scope of human creative potential and we solve all of our problems. That would be lovely. The real world, however, like even if the technology might be able to support a bunch of that, the real world is, I don't want to share my data with everybody. Some of it's really precious to me and some of it is my competitive advantage. And so I need to have security controls on it. And I want to make sure that I share it only with the people that should have access to it. And then I need to audit it to make sure that there's no unauthorized access. And so I guess in interviews, I love talking about that utopia, but I always want to bring it back around to the real world where folks that are, making their livelihood have to protect their intellectual property. And a lot of that intellectual property lies in the data and the results of analyses on that data, which is also data. So I think we have to be hopeful, optimistic, altruistic, but we also have to make sure that the capability to protect what we've developed also exists.
Absolutely, and it's really wonderful to hear someone from such a big company sort of so focused on that idea of privacy, because it is exceedingly important. I guess I'm just a bit of a dreamer at heart. I want to kind of round things off a little bit now, but I want to say that I have thoroughly enjoyed the conversation. Your insights are incredible, and it's just been a real pleasure talking to you. Even in the previous conversations, I've always walked away thinking, wow, I mean, this is a company that's going somewhere, and it was a pleasure talking to you. Really enjoyed it. Before I let you go, though, can the listeners go somewhere in particular to reach out to you, to carry on the conversation? Are there any particular places we can go if we want to learn more about BigQuery GIS at Google?
Sure. So my Twitter handle is @CWJ02. My name is Chad Warren Jennings, and I started in Twitter in 2002. So that's how you get CWJO2. So you can tweet to me there. In terms of getting an introduction to BigQuery and BigQuery GIS, I honestly suggest just in your favorite search engine, and I won't specify because they'll all return the same result, just type in BigQuery GIS and you'll land on our documentations page, and there are a whole bunch of examples. If you search for BigQuery GIS in Twitter, you'll see that there's a very active community posting tutorials and lessons. And so just look around for those search terms, and you can ping me on Twitter if you like.
Chad, thank you very much for your insights. I have really enjoyed the conversation, and I really appreciate your time.
Well, thanks very much. It was a real pleasure joining you, and thanks for your attention, and thanks to your listeners.
And that's it for another episode of the Mapscaping Podcast. My name is Daniel. It's been a pleasure being your host again this week. Feel free to reach out to me on social media. You can also find me on LinkedIn. Just search for Mapscaping Podcast host. You'll find me there. I would really love to hear from you. I welcome any feedback or suggestions you might have that might help me improve the podcast. So yeah, that's it from me. We'll talk again next week. Bye.